have a wee quick read of this. Session's being recorded. We put all this on our website after this one, and you can access it there. I think that's us. Okay, so what are we doing here? So at NZTC, we've been supporting the Robots for a Safer World initiative, which is a programme run by UKRI. It's a £100 million plus programme to look at removing people from harsh environments, space, subsea. As part of that programme, there was a sub-programme run, Subsea Autonomous Systems. We supported that with the MOD, the Royal Navy and UKRI themselves. We ran that about 2 years ago, kind of during COVID, kicked off 3 projects. Seamless is one of those projects, and Chris and I have been online quite a few times, but we've only just met in person today. So great wee project here that we're going to hear about from Chris, going into field trial this year. And yeah, delighted to welcome you to the NZTC today. Chris, do you want to quickly give a quick intro to yourself, buddy, before we get going?
Yeah, can do. So I am Chris Abbott. I'm delivery manager, so I'm quite technical. I'm not super technical. I'm lucky enough to have my very smart colleague, Luis Negro, who's technical lead on the project over from Rothko Vars, which is one of the partners of the project. He's joining on the call. So if there's anything I can't quite grasp, I'll tag him in quite happily.
Chris, well, how this works, you know, for everybody, we've had our 20 minutes of networking. We're going to get a 20-minute presentation. We'll call it, we get 20 minutes of Q&A with Chris and Pip online, which is cool. We've got a hard stop at 9:30, so we need to, in my words, boost. We are more than welcome to spend a bit more time with Chris in reception and on the stuff that you hear about today. Cool. Chris, over to you, buddy, and we'll start the clock.
Perfect. Can I steal my clicker?
Yeah, good call.
Thank you very much. Cool. I think that's all covered. A huge thank you to all the sponsors who are supporting this project. It's called Seamless. The SEAM in Seamless is Subsea Enhanced Autonomous Mapping. In short, how can we get the best gold standard of mapping underwater? And that comes from combining a number of sensors. So the project started in 2021. We're just into quarter 7 of 8 quarters, so we're getting towards the end game. We're looking to actually get it out with everything attached. We've done all of our subsystem verification. We've tried various things, but now starting to ramp up to getting everything out there, everything out in the wild, and really demonstrating that this has a real promise moving forward. So the mission, I think I pinched this directly from our bids, is to autonomously and safely map complex environments and deliver a gold standard in composite mapping. Composite mapping, essentially perception sensors of different types, all in the same frame. So you might at the moment send a vessel out to gather your wide area sonar. Cool, they come back, process that. You might send someone else out to go out and gather video or gather photogrammetry of particular assets and bring it back. But actually uniting those 2 data sources is, not necessarily a straightforward thing. So, 7 partners on the project, of which Rothko Vars, who I'm here representing, are one. We're supported by the National Oceanography Centre, D-Risk Software Systems, Sonodyne, Digital Catapults, Soil Machine Dynamics, and Stellar Advanced Concepts. This is a UK RI supported project, and if anyone's ever had involvement with those, it's as much about the sort of technical delivery of each partner as it is about actually coming together. It's perhaps rarer than we'd like that all of these really bright UK-based technology businesses who are world leaders in a number of their fields actually collaborate without contracts and pound signs flying around. What can we make that's really, really important for the industry? What can we make that's really going to progress our industry forward? So, I'll talk a little bit about it. This is a sort of an infographic explaining the mission and what we're trying to prove in Seamless. I'll skip over to the slightly more zoomed in. I appreciate the text is a bit short. But in short, what we wanted to do was, can we chuck a single AUV in, so Autonomous Underwater Vehicle. And I'll say right now, if I do blurt out loads of acronyms, I'm sorry. Those who are in Subsea know their DVLs, their INSs, their USBLs, etc. So yeah, apologies if I do, I'll do my best. Cool, so we chuck our autonomous vehicle in and we give it a loose mission. We just say, I want you to get a bit of a situational awareness of this area. Okay, goes out, does a sort of a lawnmower type scour, generating an embed sonar model. Once we've gathered that, we come back up, upload it to control station, and we start to process it through machine learning, visualization, start to understand, okay, there's something interesting there, they need further exploration. Again, at the moment, what you might find to capture that sort of information, if you're trying to consent the site, you might go out, generate the embeds, come back. A few weeks later, you might get a report, and you go through it, maybe it's some infill work, anything like that. Then we start to pick out the parts we want to go out, send another boat out, they go and look at those places. And it's just sort of adding time, it's adding money, it's adding CO2 to the whole operation. So can we do it all in one here? So come back up to surface, replanned based on the first pass, essentially to give it a target area of where we are. That's that. Oh, second one. So, detailed survey of a local area. So, SubSlam, anyone who's familiar with SLAM technology, so simultaneous localization mapping, generating a point cloud whilst moving around. Think of it as live photogrammetry, if anyone's been exposed to photogrammetry. Building that to build a 3D model of an asset. We, at this point, there's limited, if any, communication to surface. All we know is that the AUV is still alive, roughly where it is. So it needs to be able to carry out all this mission off its own back. So we have a front seat computer, and we have a back seat. In this situation, the back seat is taking over. It's making live decisions based on the information it's receiving from the sensor suite on the vehicle. So moving around, identifying the interesting assets, mapping it, ensuring it's covered it in its completeness, to then signify that the mission is done and perhaps then resurface or move on to the next phase. So I hope that's given a loose overview. In short, can we do with one vehicle in one hit with the vessel on the surface, can we get both a wide area situational awareness of the region, but can we also go down and explore those areas that warrant further investigation? Perhaps one of the clearest examples of this might be something like UXO. If you go and unexploded ordnance, right? Anything left over from the war that might be down there. We may get an embeds and start to see things, oh, that could be something we're concerned about. Okay, well, let's go down, confirm, map it, and then start to plan any clearing. So that's the pass 1 and pass 2 of the mission. There's, I suppose, with this exact application, there's less of it, but everything we're building towards in terms of the tech that goes into it enables so much moving forwards. The ability to autonomously explore an asset, whatever it may be, and all you know is roughly where it is hugely valuable. So, I'll just quickly talk very quickly on the why. Just a few headlines that I don't think needs to be surprises to anyone. 50 gig offshore by 2030. Sounds great. It's amazing. It's hugely important to the UK energy transition. But actually, at the moment, there's a few barriers to that being really attractive to asset owners, asset investors. I'll talk about it slightly, but if you're looking to get a wind farm built, you might say, okay, we'll get a boat, and it's going to go, and we'll map an area, get an understanding. We'll come back, we'll trundle through all the data, we'll plan our cable routes, we'll plan where we're going to install everything, then we'll go back out. We may need to do any clearing, we've got the actual construction, and then even once you've built the thing, you've got to come back and routinely inspect it every year. And it's a really expensive and quite a dirty business. So an inspection vessel, CO2 equivalent 20, can be over 20 tons a day, just there, while on site. And you may be on site for 20, 40 days, depending on whatever job it is. So it's a little bit dirty, it's very expensive. and we need to move more to sort of either lighter weight vessels that have a smaller crew, so autonomy starts to be involved, or starting to get the data processed live, start to do more and more in one hit rather than having to have frequent trips back and forth to the internet. Other things as well, so Seabed 2030, this is an initiative based out of Japan, but we want 100% of the seabed mapped. I think we're in, someone might in the room might just correct me, I think we're in somewhere in the 20%ish at the moment for actually how much of the seabed we know. So moving towards that. There's mapping, and you might just get a sonar image of it. But even then, you're lacking the further fidelity for things that are really interesting down there. Anything where there might be mineral-rich areas, UXO again, wrecks, Greek ships that have been lost for millennium, whatever it might be. So all these sorts of initiatives that are prevalent in the industry, and they're all things we hopefully see this tech starting to build towards as we just greatly improve the ability to map our underwater environment. I'll start to talk very quickly just about the actual partners going into it. As I said, the collaboration is as much, if not more, a part of it than the actual technology produced by any individual partners. And once I do that, I will show off the technology I can actually show off. It's saying to a few people before, just to temper expectations. We're all a little bit tied up in that. I'm sure you guys know it all the time. I actually got a little bit of back and forth this morning. So, well, actually, could you not show that? So, thank you to Rona for the last minute slide change. So, I am from Rovco and Vast, so we are the project lead on it. Rovco, very briefly, we are an offshore services industry, and then Vast make this bit of kit, which is our live photogrammetry tool. So it's called Subsea X2, and here's just a random example of what kind of thing we generate. So generating 3D point clouds live on the fly, which is a huge asset when we start to look at autonomous investigation, because the robots tend to generate a really detailed, accurate map of its surroundings, which is so key to successful information. We've got the National Oceanography Centre, who make our AAV, so our wonderful platform. If we're going to make all this tech, we need somewhere safe, somewhere reliable, something effective that can do all the maneuvers to put it all on. So AH1 built primarily off sort of 3D printed parts and polypropylene sheet, all in the interest of making some of these offshore AUVs a little bit less expensive. What's really, really cool about the AH1, and there's not huge examples of it in the industry, but it's what we call hover capable. So things like torpedo AUVs, which can fly around and map, they've been around for a wee while, but things that could hover in the same sort of, if anyone's in the offshore industry, with their ROVs, their remote operated vehicle, can move and strafe and actually explore, and that's hugely important to this project. I'm sure you can imagine the difficulty of trying to explore an asset if you can only move in one direction at any time. So the ability to strafe is hugely important. So that's the AH1, that's our sort of our carrier and for our payload and our mission. And on that, we'll have a number of sensors, which I'll talk to you about with other partners. So first and foremost, we have the SprintNav Mini on there from Sonodyne. The SprintNav Mini is small, really small form factor for its class, but it integrates both acoustic positioning and inertial positioning. So a thing called DVL, Doppler Velocity Log, and an INS, so inertial navigation system. So all combined into one to give really quite accurate positioning in space. De-risk, if we have both high value assets, whether that's the vehicle itself or actually the infrastructure or whatever it is we're inspecting, we need that to operate safely. We need to not collide, we need, if it detects any faults in the system, to come back up surface or to plan the next thing. So de-risk involved in FPGA, which is Field Programmable Gate Array, if I'm not mistaken, but essentially our mission response should anything go awry while we're out in the space. Visualisation, it's a company called Digital Catapult. They're non-for-profit. They're just looking to really help any projects in the UK industry. This is an incredibly stock picture, but imagine you go and you have an AUV going around and it maps, I don't know, for 6 hours, and you want to be able to act on what it finds. there's absolutely no point if you then have to park that for an inspection and have to watch a video for 6 hours. So how can we actually leverage the data that's collected? So from their perspective, starting to work towards building digital twinning. Digital twinning is a bit of a hot topic in the industry, in lots of industries at the moment, but essentially a digital equivalent of your whole site. Let's take an offshore wind farm like Beatrice. Could they have a full map of all of their assets, where they are in the breathing space, with the latest data that they've got? So yeah, moving to things like that. Digital twinning, useful for mission planning. So where do we want to go and inspect? And one of the things that we think is really critical, particularly if you start to look at things like preventative maintenance, can we overlay data across time? So we inspected it last year, we inspected it this year, we can see that whatever is degrading at this rate, we start planning preventative maintenance rather than having downtime. So hugely vital tool in actually coming up, being able to present that data to our users who can then execute decision making in terms of remedial work or further investigation. Advanced sensing, this is one of the particularly IP tied up ones. So Stellar Advanced Concepts took sort of recent understanding of how the whiskers on a seal can detect its surroundings, without even though maybe no visibility, anything like that. So could they make a sensor in sort of field called biomimicry, so mimicking stuff found in the natural world for that? So things like understanding that you're approaching a current, are you approaching an object which may not be visible, like sonar or certainly visibility. So quite a cool novel sensor, and the guys are hoping to get sort of a minimum viable functional demo of what that looks like. And then finally, we just needed some industry insight to make sure we were making the right thing that actually would be useful to those who own assets or to the industry. So Saw Machine Dynamics, who make some absolutely bonkers kit for the subsea industry, have just been there, helping us along the way, giving us industry contacts, giving us all the ideas that they think will make a huge value. So that's the team, I think. Yes, it is. So I'll start playing this one. So this is an example. This is live in water. This is something we actually did. And what we've got here is we have a vehicle which has an embed, so I won't explain that one, multi-beam echo sounder. Think of it as something just spinning around, plotting the floor. And that is what we see here with all of the yellow mapping. Then what we have here is a 3D point cloud that's been generated live by the Subsea system. And what we wanted to do is position these in the same reference frame. Might sound like that should be quite straightforward, but anyone who's worked in offshore knows that your positioning's a little bit off. You don't necessarily know quite where you are. You've got different sensors that weren't designed to talk to each other. So quite a complex challenge. So what we're doing here is we're building up a map. The positioning for the sonar data is being based off of the acoustic odometry, so from the SprintNav Mini, and then the visual is being based off of the subslam, so where the subslam moves, it's the 3D point cloud. And what we want to do, and one of the key technical outputs of the project, was to unify those. When we have our point cloud, we experience something called a loop closure. So if we know that something hasn't moved underwater, we maybe move all the way around it, we build up a map of it, and we come back down to a point we've already visited. The system might think it's actually a meter to the left, but on observing something that is undeniably the same asset, it can bring loops, oh no, actually, this is where you are. So can we bring that loop closure into the sort of traditional drift that you see at odometry? I think perfect timing, in about 2 seconds, you'll see the whole map update. Send that down. There you go. So quickly updates, brings everything back into the same reference frame. And we know, and hopefully we do a nice little pan down, showing that the two maps, yeah, here we are. So where we have the seabed rising up underneath the structure, and we see we've got a perfect fit between that 3D point cloud asset and the sonar. So it's a great proof of concept as how we further down the line could unify those two data types. And to bring to that, this was something we did with the support of all of our partners and as part of the project Seamless that we're undertaking. So I'll talk just very, very quickly about what that loop closure is. So traditionally, if you're offshore with a DVL, you're going to experience positioning drift. You're going to get further and further away from where you think you are. It's a sort of undeniable factor of the time you're in the water and how much you might move. Cool. So what we do instead is we start to drift and we snap it back in with the loop closure. When we revisit the same place, you say, okay, you think you've drifted, but you can't because we're back where we started. Okay, snap the drift back in. Go along a little bit, revisit somewhere you've been. No, you can't. Snap back to where you've been before. So huge credit to Sondyne for this bit of work in terms of implementing that and bringing it back. Yeah, really, really cool piece. And it might seem like it's on the surface, it's, oh, yeah, it makes sense. But anyone who's worked in underwater tech, trying to understand where something actually is no mean feat. And then finally, I wanted to show this off a bit more, but it's all a little bit tied up. But in short, one of the real cruxes of the whole operation is being able to autonomously explore an asset. What we are giving the robot is no more than a volume saying something in this 10 by 10 by 10 cuboid, there's something interesting. Can you go and find out what that is? Survey it in its entirety. Once you're convinced you've got everything you need to know about it, come back up and show us what you've got. That's where it is. I can't say too much more than that in terms of how we're doing it, but huge, exciting, and something that is where we're moving towards in terms of autonomous cars, etc. But subsea, not so much exposure to how that works. So really key. It's been a bulk of the technical work, certainly on my party side at Rugby and Vast. And yeah, really excited to, as we move forward, start to bring that out into the real world and get it alongside some assets. And I think, I'm quite happy with my timing, that is 20 seconds to spare Q&A.
Nice one, Chris. Good effort. Oh, are you good to introduce Pep?
Yes. So this is Pep. He's technical lead. He's the brains behind the operation from the Robco bar side. So I'll try to answer anything I can, but anything is a wee bit more technical, I'll tag him in to do the honors.
We don't have, I'm right in saying we don't have any mics for questions, so we can just take them. Excellent. So I used to work offshore, and I was just speaking to Chris. It's like 20 years ago. I was pretty much offshore all the time. I remember. I remember one trip we lost an ROV, so a tethered ROV. It got snagged. Tether got snagged. We ended up losing the ROV through the thrusters of the vessel. But to take the vessel back into dry dock, it was an extremely expensive mistake. You know. Impacted on the project, a lot of cost. I was a field engineer at the time, and I seem to take a lot of the blame for it. Honestly, Governor, it wasn't my fault. Sometimes I think in the industry, the tech isn't making any steps, but when I see this, it's like, it feels like night and day to me, which is great to see. Anyway, wanted to open up to the floor. I've got a bunch of questions, but does anybody want to kick us off on what they've heard today?
Yes.
Hi there, thanks for the amazing presentation. Two questions.
Yeah.
The first one, how are your vehicles powered?
Yeah.
Battery.
It's batteries, so it's lithium, yeah, like the batteries on that.
How will they last? Second suggestion, is there perhaps a use case for use onshore on dry land, not only in road?
Yeah, I think that's the bias from the industry my company's involved in. Anything underwater, that would do the business just fine. So some sort of decommissioning jobs, etc. onshore are quite interesting. Yeah, onshore is also all good. A little bit easier, if anything, without to be bobbing around on the boat.
So the second point is how long did the batteries cover last?
Yes, so I didn't make the vehicle. I'm going to quickly check if that's in my notes that I received from the National Oceanography Centre. If not, follow-up questions. All I've got is a volume, which is a 4.8 kilowatt hour lithium ion battery designed in-house. I'm going to have to go for pass on the actual runtime. As with anything, depends on currents, thrust, how complex maneuvers are. But we're looking, if I'm looking at the industry of what I know other vehicles do. Pep, I don't know if you know the answer to that. You can shake your head if you don't.
No, I don't know the right answer for that one. Sorry.
Yeah, so 2 to 6 hours, which is sort of typical for the kind of mission you need to be able to deploy. But yeah, very dependent on conditions and what we do.
Yeah, no, I'm just because it links in with Loom, which is a TechX graduate here with the battery storage. You have a docking station, so this can build on. I mean, it's tremendous. There's lots of different areas.
So was that a glider or an AUV?
It's an AUV, yeah.
NOCs.
Yeah, NOC is AUV, yeah. It's called the AH1 and it's been under development, supported a lot of UKRI and this and preceding projects as well.
Yeah.
Chris, can you just touch on that just with the H1, the field trial?
Yes.
You're planning, let's go September.
Let's go September.
Yeah, let's go September.
Yeah, as I said at the top, we've sort of done part of the subsystems on certain vehicles, part of it on another vehicle, but we're now working to unifying that all onto the target vehicle, which is the AH1. So next week, Pep will be heading over to the National Oceanography Centre to start to run very basic missions on the AH1, so starting to tie the autonomous aspects and all the sensing onto one vehicle. The AH1 itself is going offshore for demonstrations in July, I believe. So it's done quite a lot of stuff, sort of harder side of things, but going out into real open water and experiencing that. It's rated down to a 2 kilometre depth, the AH1. Yeah, off to do that. And then finally, when we come to September, the whole shebang, everything's going to work perfectly. No one needs to worry about it. UKRI can rest happily. We'll stick everything onto the AH1 and we'll do the full mission as we mapped it out at the start.
Yeah, cool. Go for it, Lewis.
What's your protocol for recovery? So if you've got a vehicle, do you need to, do you need to mobilise off a DSV?
Sorry, I can't quite
divers?
hear you.
Do you need to mobilise off a DSV and have divers hook up if you've got failure, or could an ROV hook into the PADI and recover back to deck if you had problems?
Great answer, great question. So firstly, we're taking all the necessary steps to hope we don't ever have to do that. So de-risk there who are on board sort of emergency response thing to come up. Anything that can hook onto an iLoop and bring something back up would do the business. So you can remote shut down vehicle, hook on and resurface it. So yeah, we'd be looking at an ROV to do that for safety. A lot of the applications offshore actually for this, for really starting to see the monetary benefits, have an ROV off doing a certain job and an AUV off doing another job. So yeah, you start to have all that kit available on the same vessel.
Thank you.
Just in that dead boat mode, is it negatively or positively wood? Rising the wood, so it comes to the surface and then you
Assuming it's not stuck under something.
or hit something.
Yeah.
What about the comms?
Yes.
And how, do we have different systems on this for the communications? Also interested in how much data are we sending and processing?
Yeah.
And on that side,
So everything we're doing is to be able to do absolutely everything we can on the AV itself, because we are limited to acoustic comms on this. I don't know if you've got any info on the...
Yeah, so the sensors, the perception sensors, they produce a lot of data per second. So in particular, for example, SuperSlam cameras, they output 2K images at 20 hertz. We obviously compress the images, but then we have two sonars, a forward-looking sonar and a down-looking sonar. They also produce a massive amount of data. So internally in the vehicle, we have a gigabit network, obviously, to allow the different computers to communicate with the sensors. But we try to process all the data on board and then, just communicate to the top side the position of the robot, or if there's a failure, or things that require a very small bandwidth. Yeah, that's basically it.
Yeah, so just to confirm there, a lot of this, it's all autonomous. But the stuff you're sending back is pretty much a ping on the location of the vehicle.
The location and yes, I'm still alive, maybe a battery status, enough to make incredibly stay down or surface decisions. That's about
All
all
acoustically.
we've got.
Yeah, that's great.
You can also abort the missions from topside if you want as well. So you can also send commands to the vehicle, some safety commands. But all the maps that the vehicle is generating by itself, those maps are transmitted when the vehicle is on the surface. Then we've got a radio frequency link, and we can transmit the huge maps when the vehicle is on the surface. Yeah.
So acoustic comms, I get it, because that's what you're kind of limited to. Is part of the program, once we've established how well we can get the autonomous side of it and all the mapping, is there a view to try and look at alternative communication methods to actually make it more live, rather than just pinging its position? Is that on the radar of thought process, or are we going to, because that is the limitation on these vehicles. Obviously having an ROV tethered, it's very much direct communication.
I think from my perspective, I'll say in the scope of this project, no, in terms of what we're actually trying to accomplish by September, no, but I think we're planning to do everything on the vehicle. What having much better communication to it helps with more than anything is confidence. So confidence for those that are deploying it, confidence for those asset owners. When we start to look at can we even test this at a client site, we go, oh yeah, we won't really hear about it until every minute or so we might find out where it is. Starts to become a little bit less sort of appetizing as purchase owners. If we start to move to much better quality communication, so look, you'll be able to monitor the whole mission the whole time, you can see how it's working, then from my perspective that's huge for industry adoption. But the way we're designing it to actually execute the mission, which is to generate this complex map autonomously, we hope to achieve without them. It's my view on it. I mean, it's not biased, but that's my view.
Typically, what range and depth are you working in from the surface to where the AEPs are?
So only limiting factor on that from our perspective is the depth rating of the hardware itself. It shouldn't care so much where it is. The vehicle said it's rated down to 2K. I think one of the sensors on the moment is only down to 300 meters. But again, I'm perhaps biased from our perspective. The place we see this is consenting sites or consenting to service sites in the UK offshore. So fairly shallow depths relatively.
Sub 100.
Yeah, but there's no reason that it couldn't work down. You start to struggle a little bit more with visibility perhaps down, and certainly the camera sensor, it will just take a little bit longer to build up that comprehensive map, etc. The more turbid the conditions are. Yeah.
So if there was a technology available which did close that loop, in other words, remove the tether, and you had real-time communications at megabit, at 100 meters plus, close up, gigabit per second, would that be interesting?
Certainly, as I said, on the confidence and assurance things, if with anything making a mission more efficient, at the moment we would scour, come back up, go back down to investigate. We're instantly getting much better sort of efficiency in terms of the battery and the mission time if we can make that large decision making at the moment. So there's nothing to say that we can't move the computes that recognises that scene and where to investigate onto the vehicle. But yeah, planning on the fly rather than just following pre-programmed missions, I think for me is what that really would enable as you gain situational awareness.
Have a bit of tech in the back pocket.
It exists. It exists.
The technologies in the public domain are for Mike's working on. And this programme is ideal for it because it takes what you're talking about just now here, acoustics, and then supercharges it with this subsea Wi-Fi, Li-Fi system. And then that really takes it to the point because people can get real-time feedback. You can still process data there, but the fact that on the surface you know exactly where you're at, you know what to do, and instead of having that come to surface or stay, you can actually give it pass back and forth.
So it's real-time human supervised intervention. So it's cutting it.
So that technology exists. It's on the UK Energy Technology platform. Something we can maybe talk about later on. And then the other thing which fits into NZTC and the Alta project because obviously we looked at surface first and the robots and the drones, but Subsea is very much in the long-term project. Are we aware of other projects that are this far on with autonomy? So a lot of people talking about it, but hard to find, apart from deep starts and projects that we're working on here, it's hard to find real things that happen.
So there's 3 projects doing slightly different things, but the same level of autonomy under this Subsea Autonomous System Programme. So we had one a month ago. So if you go online, you'll see a programme called Demeter. What is it? Demeter. Okay, we'll go with that.
I think.
Yeah, have a look online at our Tech20 website, Colin. You'll see something on there. We might end up getting the 3rd one presented at Tech20 later on this year, but if you're interested in it, just give us a shout and I'll contact you.
Just think you could join the dots here.
Oh, for sure. On all 3 of the projects,
Supercharged.
comms is like, and certainly subsea comms is a challenge. None of them are taking that step into Li-Fi areas or higher sort of like bandwidth comms, if you like, which is fine, you know, but it'll come, you know, and we need it. So it's the right tech to be looking at if you're.
And the thing is, it's proven now we'll be able to talk about Deep Start project, what's going on, but they're in isolation in their bubble, which is nowhere near over here. So we need to join the dots and have them everybody talking to each other. And NZTC is the perfect place to land up.
Hey, I had a question. So you'll see this, it's a great sort of consortium of companies. We've got SMD, Rovco, well-renowned sort of industry players, and then a lot of centres like NOC, Digital Catapult, and so it just has a great feel about it. What I wanted to ask, Chris, is just on Rovco. So, you know, they're local up here, Northeast. I knew one of the lads that set it up. It's a great success story, if you like, in the Northeast. But I'm just interested, you know, how VARS came around, and it would be worth you just explaining to the audience, like, how that setup works.
Yeah, I'll try not to steal too much of my CEO's pitch for it, but there's different approaches, I suppose, in the offshore services game. There's just looking at efficiencies, I suppose, and how you can do that, and just operational excellence. The place where there's less people making headway is technical innovation. So Rovco, VAST are the same company. VAST is the research arm that feeds a whole load of tech. So everything we've seen with the subslam camera, everything for the autonomy, for the combined mapping, is stuff that's getting generated by VAST, build forward into Rovco and start to achieve, really cutting edge business and to succeed in the industry that way, because it's when you've got huge players like Fuga out there that financially can blow out the water, you've got to do something a bit different. And we're in a really privileged position because we are smaller. I know exactly who is off on a certain dial asking them to try the tech that we're doing, and you can be much more agile in terms of how you get that tech out into the industry that way.
Yeah, no, I think it's just an interesting setup. I think it's really good. And the VARS location, you're based?
And Bristol.
Yeah.
Bristol. So we've got Rovco have just over in West Hill actually is the offices and warehouse. It's not far from here. And then the Rovco's based down there, so where our sort of all our senior leadership based down in Bristol. The VARS, based down there.
Cool. Can I ask also just about industry? You taking this to industry yet? You speaking to any wind developers? How's that going, or have you taken that?
What can I say? As a consortium, not altogether, but individual partners are always engaging with their industry. It's one of the big talking points in UKR. There's no point doing all this stuff, getting to the end of the project, doing a cool demo, sticking it in a filing cabinet, not picking it up again. So starting to approach industry, we're perhaps not at the technical maturity level yet, I suppose, to go in and blow them out of the water.
Yeah.
This is a great opportunity to get that feedback and get people excited about what it could do. But yeah, we always say, I think the real R&D valley of death, you get sort of your TRL 6, whatever, and then actually trying to get industry adoption. Oh, what happens if this happens? Oh, well, we haven't actually tested that yet. And it becomes so much harder to get out there. So yeah, looking for those industry partners and some who are much more R&D sort of focus, and I think they realise that if they want to be sprouting up wind farms all over the shop, something needs to change in terms of how that is serviced.
There must be something in InTog somewhere.
Well, I say, Chris, I think it's what's great about the technology centre. Maybe I would say this because I work here. Is we're not like we're not all like academics here. We're not all serious technical experts in a wide range of fields. What we do have, though, is fantastic industry engagement, industry connections, and a way of bridging that valley of death. Is that what we call it?
It's the R&D valley there. You used to see this like adoption drop off.
That's not one, but that's a
I
USP.
feel this is an easier one to bridge that gap, because simply all of the survey work that's going to be even required for simple couple of wind turbines for InTog.
I know.
Forget the big stuff right now for Scotland, because we're not there yet, but
Taking the
InTog,
step, eh?
just, it's, the risk of bumping into what? It's going to be on an MTC bed, right? I think there's an opportunity here in InTog,
Yeah.
more than probably any other technology in this
Even
space.
on the comms front as well, and setting up.
So yes, so currently, as in Monday, we did our InTog conference, and the InTog, of course, the in is the innovation. So we set the conference in. The first one was TOG, which is as far as getting the targeted oil and gas. And they are thinking, well, we're 200 kilometres away from shore, we needed to work with proven technology, so they are very, very risk averse thought process in there. Then there's others within InTog where are saying, well, innovation is how we won the license. So we are open to it. Now, what they're missing is the demo. They're missing the fact that somebody's gone and done it. Roscoe,
We're good at robotics, we're rubbish at marketing.
So, like intended double, with NZTC joining the dots together, with things like the wave buoy, generating power, the Verloom with the battery, with the station in there to recharge your AUV, with the comm system, you've actually got something. But we've got to work together, because there's also really neat innovative sensors in here, which don't have an AUV to connect onto, which don't have a host. And the operators that we're part of, just presented to the technology managers now, they are up for it, but they need to see some tangibles. And then you'll see some horsepower coming behind it. But don't pick off one operator or another. Let's talk to a number of operators in a joint project, and I'll put some horsepower against it. Because you said right away, we cannot have, there aren't enough vessels out there, by the way, anyway. ROVs, but when you think about this, even InTog, these wind farms are going to be the size of Dundee. I mean, it's enormous. Mapping it, keeping it, maintaining it. Then you've got oil and gas, it's still going to be here. And then you add in hydrogen and CCUS. It's massive, so it's got to be autonomous. And so well done for that. And definitely, I mean, keep in touch through there. I'm in and out here constantly.
I use Graham as my agent.
He's
Awesome. I'm looking at the clock and it's 0000 and it's after 9:30 and I'm going to get shot. So, Pet, thank you very much for joining us. That was okay. Chris,
Thank you all.
Thank Chris. If there's more chat, take it into reception. Thanks for making it. Cheers.